things, remember we've proven a few angles, right? So let's just look at some of those angles that we found. We found B3 equals X, right? And we found that X was the same as A1, E1, D, and A2. Now, the following question says prove that AECB is a cyclic quadrilateral. Now, what is a cyclic quad? Well, simply put, a cyclic quad means it's a quadrilateral that is drawn within a circle. So, let's get a circle. That's a circle. A cyclic quad is any quadrilateral, for example, the one that I'm drawing now, as long as all four vertices are on the circumference of that circle, then it is considered a cyclic quadrilateral, right? My bad, sorry, there we go. There, it's back. That's a cyclic quadrilateral. If I drew a square, but I inscribed it inside that circle or on its circumference, triangle, let's take a rectangle. This here is a cyclic quad. Why? Because all its vertices, all four, lie on the circumference of the circle that I am interested in. Does that make sense? Okay, so what do I really want now? What I really want to look at this point in time is saying, let's consider AECB. Let's consider AECB. There is AE, right? There we go. AECB, right? And back B to A, because we join A to E, E to C, C to B, and B back to A, taking it directly from the name. Now in order for this to be a cyclic quadrilateral, what we really are interested in is saying, can this thing be drawn in such a way that all four its vertices, okay, now I'm just playing around with things over here, all four its vertices lie on the circumference of a particular circle. For example, like so. That is what I'm interested in at this point in time. Okay, now remember there are certain properties about cyclic quadrilaterals, right? One is the exterior angle of a cyclic quad. For example, C3 equals the interior opposite angle. So if I move inside, I must go opposite. If C3 equaled A1 plus A2, then we can consider this a cyclic quad. Or if I took C1 plus C2 plus A1 plus A2 and I sum them all up, if I got an answer of 180 degrees, I mean, yeah, they are supplementary, then that is a cyclic quadrilateral. Now those are the basic ways of proving things are cyclic quads, but then this particular question is a little bit more tricky. So another way that you must remember that I can prove that something is a cyclic quadrilateral is all I need to do is I need to show that whatever happens to this thing, it holds true for the conditions for Euclidean geometry or when those things take place in a circle. So this question is pretty straightforward. Earlier we proved that B is equal to B3 is equal to X, right? Now, if I told you that B3 is equal to X, if this is a cyclic quadrilateral, then from that point to that point, remember these are E and C and B and A are points on the circumference of that circle, then I can say that this angle here is equal to X, right? And if I find, for example, over here, that same point there, between and that point there, I'm just coloring it in, doing a very bad job actually, but let me color it in over there, right, to that point on the circumference, and this point over here, that's A1. So B3 is equal to X, which is equal to A1. But this has been proven previously, right? It's been proven in 10.2.2, because remember we found a series of angles over here that were all equivalent to X, and we found that A1 is equal to X. So if I go back here, I can see A1 is equal to X, but B3 is also equal to X, and both of that is angles on same segment. Okay, let's write neatly. I know it's the middle of the night, but that's no excuse. angles on the same segment. Now, usually it says if the angles are on the same segment, right? If a segment obtains the same angles, then they must be equal. Now here we are using the converse, right? We are saying we've shown that the angles are equal, therefore they must lie in the same segment. And that theory or that theorem only works if we are working within a circle or it's a segment on a circle. So I hope that makes sense. If it doesn't, just take yourself a little bit backwards and say what we're really trying to show is that this theorem that I applied, or these 4 points, are inscribed on the circumference of a circle. That's what we really want to show. We want to show that these 4 points lie on the circumference of a particular circle. Now, in order to do that, I showed that A1 is equal to B3 previously, and I can say that A1 and B3 lie on the same segment EC. And so because they're on that same segment, because they were equal, I can conclude that whilst I can witness they're on the same segment, they must be part of a cyclic quadrilateral. Now I say therefore AECB is cyclic quadrilateral. Oh my word. That's an I. There we go. Again, that's 10.2.3.